Hi there everyone, thanks for joining us today for another video from Markforged Systems. This is Jesse Hallworth, Senior 3D Printing Application Engineer, and in today's video I'll be talking about a brand new software update from Markforged that will allow users to create fully custom continuous fiber groups anywhere in their 3D printed parts. Traditionally, fiber is inlaid into Markforged parts in either a concentric pattern along the walls of geometry, or in an isotropic pattern that fills an entire layer with continuous fiber. While both of these automated options can produce fantastically strong parts, the ability to directly control the placement of fiber anywhere inside of a part will let Markforged users enhance their parts with fiber more accurately than ever before. So we'll go ahead and jump right on into it with this fully sliced gripper part. We currently don't have a fiber selected, and while you will want to set a fiber here if you know what type of fiber you are going to print with, for this example, we'll start by leaving this material option set to none, which will allow us to fully customize our fiber. Next, we can click on the X-ray option, which will open up the internal view of our part. For this specific part, there are going to be two areas that we'll be reinforcing with fiber. The first will be the gripper feature itself, and the next will be the two through holes so that they will be resistant to any clamping forces. We'll start with the gripping feature, and for this example, we will start by selecting one of the layers near the top of said feature using the layer navigation bar. Once at least one layer is selected, we are able to utilize the Create New Override option. Since we want to add fiber to an area of our part, we will choose the Add Fiber option, which will begin to add fiber to the layers we have highlighted on our part. Once our override group is created, we're able to start the process of defining our custom fiber groups by using the Add Sketch option. For those of you who have previously watched our custom Markforged supports video, you'll find that the functionality here is pretty much identical. Users will be able to draw several different shapes, rotate them, move them around, and even resize them as needed. We can easily move this sketch to cover the whole gripping feature, and we can also add as many sketches as needed to any group in order to truly define where we want fiber. Sketch shapes can also be individually deleted as well if needed. Once we have our sketch in place, we'll simply press Finish Sketch, and the software will start to reorganize fiber placement to match only where sketches overlap part geometry. Override groups can be fully modified after they are created, down to the fiber fill type, which we'll do now for this group, as well as the number of layers that this group covers, which can be done using the Layers slider on the navigation bar. Now that we've added some extra stiffness to our gripping feature, we will next do the same with our bolt holes. You are also able to create override groups by first selecting a large number of part layers, so we'll start this second example by highlighting all of the layers occupied by our holes. Once fiber has been added to this entire group, we'll start the same process of defining our fiber boundaries using a sketch. Note that you are still able to navigate the layers of your part while you are adding override sketches, which is super helpful when sketching around features that change sizes like these holes do. This is just another simple sketch, as we're just going to use one rectangle to fully cover both of these holes. Once we have our sketch in place and have saved our changes by selecting Finish Sketch, Eiger will automatically start to get rid of fiber from any area that we didn't define. And once the process is complete, all we would need to do is save our changes, and the part would be ready to print. As you can tell, it can be pretty quick and easy to place multiple custom groups of fiber inside any given part. As you work on a part, you can easily tell which group is which by hovering over it, which will highlight the sketches belonging to that group. And don't forget, you're also able to follow this same workflow to remove fiber from an area if that is easier based on your specific geometry. Now, one of the super interesting things about this update is the fact that custom fiber groups can have their strength verified by Eiger Simulation. So in the case of something like this end of arm tool, users would be able to set up their own fiber groups that reinforce critical areas, while also being able to verify that those custom settings will be valid for their application. So we'll start the second part of this video with our fully sliced end of arm tool that already has fiberglass reinforcement enabled. If we go to the X-ray view of this part, we can see that by default, Eiger will place a few layers of isotropic fiber on the top and bottom of the geometry, which will give the part good strength in all directions. Before customizing our fiber any further, we'll go to the Simulation tab for this part so that we can start to get an idea of where this part will need fiber. Our first step will be to set up a load case for the part, and we'll start that off by first marking these bolt holes as the anchors on our part. And next we'll mark the main interfacing feature as the load surface, while also reversing the load direction to go inward by clicking on the blue arrowhead. Next we'll define our expected load amount to be 250 newtons, which is about 56 pounds of force. We also want a bit of a safety buffer while this part is under load, so by setting our safety factor to 1.5, this part will be simulated to withstand a bit over 84 pounds of force. Lastly, for our load case, we'll set the max deflection of our part to 0.5 millimeter so that we can ensure that the part is simulated to be extremely stiff while under load. Once we save our sim case, we can start to validate the results to find out whether or not our current print settings will withstand the expected load. This next step does usually take a few minutes, so we'll skip ahead really quick to check out the end results. As you can see, the part does deflect more than we would like with our current print settings, and it also does not meet our set safety factor of 1.5. If we use the displacement slider on the bottom of our screen, we can see that the tool does start to deflect near the point of contact while under load, and it also does start to lift off of one of the anchor points. So it's pretty clear that we need some additional print setting changes to make this part strong enough to survive our load case. Before we move on and create some customized fiber settings, a good first option here is to see if Simulation does have any viable alternatives for printing a successful version of this part. So we'll start the automatic optimization process, and just like a network TV cooking show, we'll quickly skip ahead to take a look at the results. Taking a look at our options here, we can see that under the optimized area, we do have an automatic print option that will meet all of our load case requirements. By selecting the option to apply this optimization, we're able to reslice the part, which then lets us go back to the X-ray view and see what Eiger has changed about our part internals. Quickly looking at our part, we can see that the simulation software has expanded the initial sandwich panels of our part, while also keeping the isotropic fiber pattern for both of these groups of fiber. This additional fiber does increase the print time and cost of the part, but the advantage here is that we now have a part that we know will work for our application with very minimal input or time on the user side of things. But why don't we go ahead and see if we can do better? Going over to a copy of our end of arm tool, we'll leave fiber material turned off so that we can manually place the reinforcement material where we think it is needed. So just like in the first section of this video, we'll go to the X-ray view of our part, and this time we'll start our fiber override group by selecting all of the layers in our part since the geometry is fairly symmetrical in the Z direction. Once our fiber group is loaded, we'll start the process of placing our custom sketches to tell Eiger where to place fiber. If you recall from earlier, our part starts to deflect under load near the main interfacing feature, while also deflecting near the bolt holes as well. So the first thing we'll do is to add a sketch in the area where our first bolt hole is, and then we'll add another larger sketch along the angled part of the arm so that the fiber here can act as a brace when the part is under load. Next, we'll quickly reinforce the area where our second bolt hole is, and then, as a last step, we'll reinforce the area surrounding the main gripping feature of our tool to give it some additional stiffness. Once we have all these sketches in place, we'll let Eiger route fiber into these areas, and as you can see, any sketches that overlap will transform into one continuous fiber group during the slicing process. And the very last step we'll do here is to change our isotropic fiber fill type to concentric, since this part is really only going to be under load from a direction parallel to the print orientation, which is a fantastic use case for the concentric fiber type. Of course, the whole idea of this section was to use simulation to verify our custom fiber. So once our part is fully sliced, we'll head on over to the simulation area once again, where you can see that we already have the same load case as before set up for this part. Now the last step here will be to verify our new print settings, and once again we'll fast forward to the final results where we can see that not only do our custom settings meet our safety factor, they will also prevent the part from deflecting more than 0.5 millimeter while it is under load. The additional time spent setting up and verifying our custom fiber group also has some fantastic cost benefits, as this new version will reduce our material costs by more than 33% compared to our original simulated copy, while also printing 8 hours faster. So whether we print one part or dozens, we're going to see these parts put to use quicker, while also knowing that they are valid for our specific application. Thanks everyone for taking the time to watch our overview of this new Markforged fiber software update. The ability to draw custom fiber groups lets users have more control over their parts than ever before, and we're really excited to see what everyone does with this feature. Let us know in the comments what parts you'll be using this on, and feel free to subscribe in the Hawkridge Systems YouTube channel to stay up to date with more content like this. Thanks again everyone, and happy printing.